Hello guys, and welcome to a video on Pythagoras' theorem. Today we're going to be working through exercise 3b, finding the length of the shorter sides of a right angle triangle. And we'll be working through a few examples. Basically though, we want to substitute the known values into Pythagoras' theorem, and then we're going to rearrange that equation to find the side length that we're missing. Okay, just a quick note here. If you get a value as a surd, unless otherwise stated, you will want to leave that as a surd, which is the exact answer. Okay, we don't want it generally rounded to a decimal unless stated, which is what this one is down here. Okay, let's have a look through this example. All right, so we have a right angle triangle. We're given the hypotenuse, which is this long length over here. Remember, the longest side of a right angle triangle we call the hypotenuse, and that's opposite the right angle. And then we're given another side length up here, but we're missing this side length labeled A here on the right. So if we just start the way that we would start any problem, we'll start by writing down the formula for Pythagoras, which is A squared plus B squared equals C squared. Okay, now if we substitute the known values in, okay, so we're gonna stick with A. We're gonna leave A by itself for now. So we're gonna write A squared, and we're gonna label this side B. Let's say that 24 equals B, and we'll say that C, the hypotenuse, equals 25. So we're gonna substitute 24 in for B equals, and substitute 25 in for C. Okay, evaluating those numbers there, so 24 squared is 576, and 25 squared is 625. All right, we want to get, essentially we want to end up with A equals something. So some inverse operations here. If we subtract 576 from both sides, I'll just do that here. We end up with A squared equals 49. All right, and now to get rid of this square over the A there, well, we need to take the square root of both sides. So if we take the square root of both sides, we end up with A equals 7 in this case. So we found that the missing side length in this one was equal to 7. Okay, let's look at another example here. Okay, this time we have a decimal number here, so we're actually going to look at rounding this one to a decimal value. Okay, so again, if we just start off with the formula, A squared plus B squared equals C squared, and then just substitute those known values in. This is the longest side again, the hypotenuse, because it's opposite the right angle. So we're going to let that one equal C, and we're going to let this one here equal A because we've already got B over here. So we're going to substitute those values in. Plus B squared equals 12 squared. Start evaluating those. You'll probably need a calculator for this one because I don't know what 6.2 squared is. So I'm going to open my calculator there. 6.2 squared happens to be 38.44 plus B squared, and 12 squared is 144. Okay, again, we want it to say B equals something. So we need some inverse operations here. We need to subtract 38.44 from both sides. So I'll do that. So we get B squared equals 144 minus 38.44. All right, and I open my calculator again. 144 minus 38.44 gives me 105.56. 105.56. Okay, and again, to get rid of that square root sign, to get rid of the square, we need to take the square root of both sides. So we're going to end up with b equals square root of 105.56. Okay, let's evaluate that. So we can take the square root. Remember, the square root over here on the CAS is control, and then we want to press the button which has the x squared on it. Okay, so it's 105.56. Press enter, and we get 10.2742. I'm going to round that to 2 decimal places, which is going to be 10.27. Okay, and that's the value for B. So we found the value for B there. Again, you can always check that you've got the correct answer, because your value there, 10.27, it should always be less than the longest side, which in this case is 12. So it is less than that. So we would be confident that that's the correct answer. Okay, let's look through one final example, a little bit of a different example here. So in this right angle triangle, we can see that we have a hypotenuse equal to 7. Okay, so we can say C equals 7. And we have these other two sides, but these other two sides you can see by this little annotation there that these two sides are equal. Okay, and they're labeled x. So let's just start again by writing out the formula. A squared plus b squared equals c squared. All right, now instead of a and b, we're just going to have x. Okay, so we're going to write x squared plus x squared, because they are the same. Remember, x squared plus x squared equals, now instead of c, we're going to write 7, so 7 squared. Okay, and evaluating this left-hand side, what is x squared plus x squared? Well, there's one lot of x squared, and there's another lot of x squared. So we're going to have 2x squared equals, and now what does 7 squared equal? Well, that equals 49. Okay, now we want to essentially get x equals something over here. So the first thing we want to do is to divide both sides by 2. So if we divide both sides by 2, we're going to get x squared equals 49 divided by 2. Okay, and then we want to get rid of that square there, so we're going to take the square root of both sides. So we get x equals square root of 49 divided by 2. Okay, and if you like, you could evaluate that a little bit further, because the square root of 49 is 7, so we get 7 divided by root 2. Okay, and that's it for that type of question. So guys, get into the exercise. If you'd like to read through the key ideas a little bit more in your books, you can. But that's essentially it for this chapter, for this exercise. Feel free to ask any questions on our class page if you're getting stuck with anything. Okay, see you guys. Thank you.